Welcome to today's session. I know it's the last session of the day, so we'll try to finish early if we can. Thanks so much for coming. This is on secure media streaming and delivery. My name is Nihar Bihani. I'm a product manager at Amazon Web Services, and I also have Usman Shakil here. He's a solutions architect with Amazon Web Services. It always fascinates me how many different types of use cases that customers use AWS for. Both Usman and I, we talk to a lot of different customers, and variety of different industry verticals, variety of different types of use cases. But focusing on today's topic, secure media streaming and delivery, when you think about that, those types of use cases, even there, we have folks across the spectrum. We have use cases where, for example, my mom, she has a video that she wants to upload into AWS and then share it with me, my sister, the rest of the family. We have companies like Netflix that are storing and delivering premium content to all of you. And we have studios that have pre-release content that they just have to make sure that it's completely secure. No one has access to it before a specific date and time when it's supposed to be released. This is Hollywood content. So all of those use cases can be supported by the different AWS services and the features within those services that we make available to everyone. So with that, let's look at the agenda. Oop. There is no agenda. I'll just walk through the agenda. From an agenda perspective, the way we'll talk about, actually, this is just a second. I don't think this is the right deck here. So can we just switch over to the deck over back there? Yeah, for whatever reason, this is not the right. And then we'll need the clicker as well, please. Yeah, I'm not sure why. Thank you. Sorry about that, guys. Okay, there is an agenda here now. So from an agenda perspective, the way we have structured the talk is we'll first quickly talk about just an overview of secure media streaming, and when Usman and I were talking to different customers, what are the different security components and controls that we hear them using for different types of use cases. Then we'll talk about AWS services and what features AWS services provide if you wanted to put some of those security controls in place for your specific use case for delivering your media content. And then we'll do two demos. The first is a video on demand demo, and the second is a live demo. And in both cases, we'll present the architecture, the different AWS services that we are using to build up the stack to secure and deliver that on-demand or live content. And we'll go through some of the best practices as well. So let's talk about the secure media streaming overview. So if you look at this chart, the key takeaway from this chart that I'd like you to have is that there's a whole spectrum of use cases. And what level of security and controls you put in place really depends on your specific use case and how valuable that content is, or how you're monetizing that content, or how much security you need for that content. So for example, if you look at the free or publicly available user-generated content use cases, there, oftentimes media publishers or customers, they'll just keep that content completely open. Anyone can access it, come and view it, download it. But as you go further down the list of use cases, you'll see premium content or pre-released content where there are media publishers like Amazon Instant Video or Netflix or studios that have this pre-release content that they use things like AES encryption to encrypt the content, signed URLs, digital rights management, watermarking, all of these different controls in place to make sure that the content is protected to the extent possible. So as we go deeper into the presentation, I just wanted to present this slide and sort of a level set in terms of what are some of these controls that are available to you and that we hear customers use. So the first one, token or signed URLs. Here, there's a policy statement that you include as a part of the URL or as a part of a cookie that you write on your user's device, which allows you to restrict or allow access to different users based on who has the signed URL available to them. So for example, this is a tool that someone like my mom could use when she's uploading and sharing the video with the family so that no one else can have access to that. AES encryption, that's essentially encrypting the bits so that even if somebody does get access to your media files, they cannot decrypt it, they cannot view it, so it's essentially useless to them. DRM, or digital rights management, that's similar to AES encryption, but it adds a layer of business logic to that, where not only are you encrypting the content, but you're also providing things like you can only have access to this file for a certain period of time. So there's some business logic applied to that. And then geo-blocking allows you to restrict access to content based on where the viewers are located geographically. So if you have licensing rights only to distribute your content in the United States, for example, then you can use geo-blocking as a mechanism to block access for viewers that are outside the United States. So encryption, DRM, geo-blocking, you'll typically see these tools used by media distributors, for instance, someone like Netflix or Amazon Instant Video, where, for example, with geo-blocking, if you've traveled internationally and tried to access Netflix from outside the United States, you cannot. So that's geo-blocking in place there. And then finally, watermarking is a tool that you'll often see studios use, because here you can actually put a unique watermark or a fingerprint on the video file itself before distributing it to your different partners, for example, so that if there is ever a content leak, someone unauthorized has access to that content, based on the watermark what that source of leak was, and then you can go and fix that. So let's talk about AWS services and some of these security components that we talked about and how that applies to the AWS cloud and the different services we provide. The important thing to remember here is that AWS is not just for delivering your video or your media content to your users, but you can use different AWS services for all the different components in your media workflow. So all the way from ingesting the content to storing it, to processing it or encrypting it or transcoding it, and then finally delivering it to your end users. And depending on your use case, you can use different types of services to build the exact workflow with the exact features and the security requirements that you have with different AWS services. Specifically in this talk, we'll dive deeper into Amazon CloudFront for delivery. We'll talk about Amazon Elastic Transcoder and Amazon EC2 for processing and encoding your media files. Talk about Amazon S3 for storage, and Amazon EC2 from an ingest perspective, particularly for a live streaming use case where you're running a media server on EC2 and that media server acts as an ingest point, and that's ingesting the live feed, transcoding it, and then delivering it. So the AWS services that we just talked about and some of the security controls we listed earlier, what I wanted to do is highlight specific features and services where you can put those controls in place using different AWS services and the features that are available. So for example, with token or signed URLs, you can use Amazon CloudFront's private content feature and enable this functionality so that only users that you authorize that have a valid signed URL or a valid signed cookie can have access to your files. For AES encryption, you have Amazon Elastic Transcoder that provides AES encryption for HLS and smooth outputs. So your the output chunks or the fragments will be encrypted. And also the AWS key management service It integrates really well with the Amazon Elastic Transcoder service, with EC2 and S3 to manage the encryption and decryption of your keys. For DRM, you can use Amazon Elastic Transcoder again. Transcoder recently launched support for play-ready DRM packaging, so that's now available to you. For geo-blocking, CloudFront natively provides the capability for you to whitelist or blacklist countries where you want to or don't want to serve your content. And then watermarking, again, Elastic Transcoder provides you the capability to include watermarks as you're transcoding your content. So, all of these features are available. Again, I keep going back to it really depends on your specific use case and which of these security controls you need to put in place based on what type of content you have, who you're delivering it to. So let's look at a simple architecture diagram for both on-demand and live. We'll start with on-demand. So at the very right, you see the media file that you can upload to Amazon S3, store it in an S3 bucket. That S3 bucket then becomes the point of origin for the Amazon Elastic Transcoder service. The transcoder service will pull the file from S3, transcode the files based on your requirements, and then put the output of that job back into another S3 bucket or the same S3 bucket. And then the second S3 bucket becomes the point of origin for Amazon CloudFront, where CloudFront can then pull the files from Amazon S3 and then deliver it to your viewers who are using different devices to access that content. Between Amazon S3 and Amazon CloudFront, you can restrict access to that S3 bucket such that only CloudFront has access, and only CloudFront can go and get those files. You can also enable HTTPS so that the files are encrypted in transit. Between Amazon CloudFront and your viewers, you can again enforce HTTPS so that these files always are encrypted and go over HTTPS connections. And you can do that for HLS, Smooth, RTMP, and so on, different formats that are supported. For live, you look at the bottom. Again, if you start on the right, you have a device that's capturing the live video. And then that live video is being uploaded to an Amazon EC2 instance and a media server that's running on an EC2 instance. You have a wide variety of media servers that you can run there. It could be a Wowza media server, an Adobe media server. It could be nginx. We'll use nginx in our demo later. And then that media server will do the transcoding of that raw input that is receiving of the live stream in real time. And CloudFront can again go to this media server on EC2 and use that as the origin point, pull the live chunks and the live manifest files that are being generated, and then deliver it to your viewers. Again, the connection between the media server and CloudFront could be over HTTPS. And HTTPS, again, between CloudFront and your viewers. And you can, from a format perspective, you can do HDS, HLS, Smooth, all HTTP-based formats for doing live streaming. So let's dive deeper into the services that we talked about. We'll start with Amazon S3. So Amazon S3 is our simple storage service. This service is essentially where your video files will live for your media delivery use case. And when you're using Amazon S3, some of the security controls that S3 offers, these are access controls that are there in S3 by default for all different use cases. So, by default, you get bucket level and object level access control with S3. So when you first create an S3 bucket and upload a file into S3, only you, the owner of that bucket, has access to that file. That's by default. Now you can open up access and give others access, whether that's other people or other AWS services, but you have to explicitly do that. So a couple of ways you can do that. You can use signed URLs or query string parameters to restrict access to a particular user, so only user that has that valid URL can access the file. You can also use IAM policies. IAM is AWS's Identity and Access Management Service, and you can use that to define different groups or roles or users that have access to that entire bucket or individual objects in that bucket. And then, in addition to that, you can also use versioning for content that you really want to make sure that never gets deleted, or you have full control over who deletes it. So versioning allows you to, or prevents you from accidental deletion, where even if the content is deleted, you can go back to the previous version. And you can also enforce MFA delete, where you require the user to have an MFA token before they can actually delete a file. This way, that adds just another step, another layer of security before somebody can delete the file. And even for users that have access, you can enable S3 access logs so you know who's downloading the content and accessing your content. So all of these different security controls and access controls are available to you. And aside from access controls, let's talk about encryption and how you can enable encryption on the file, whether it's in transit or when it's stored in S3. So from a transit perspective, we can look at S3 client-side encryption. So here, the file is currently in your data center or in your premise, and you can use the AWS SDKs, and there are a variety of different AWS SDKs that are available to do client-side encryption. The way that works is you have an envelope key that's generated by the SDK. You use that envelope key to encrypt your content, your media files first. You also then use a master key to encrypt the envelope key itself. And then both the encrypted media file as well as the encrypted envelope key can then be sent to S3, maybe even over an HTTPS connection. So that's another layer of security. And then stored in an encrypted state in S3, both the media file as well as the envelope key. When you want to access or download the file, the same thing applies. The download will be in an encrypted form. So both the file as well as the key will come encrypted back to you. And then you can use the master key to decrypt the envelope key, and then you can use that to decrypt the media file. You can also, instead of using or managing the master key yourself, you can use AWS's key management service, and that will manage your master key or generate a master key for you and take care of the encryption and decryption of the key. Amazon S3 also has server-side encryption capability, and this is as simple as checking a box. You go to the management console and check a box, and then server-side encryption is enabled. The way that works is S3 has a feature for encrypting your media files at rest when the file is inside of S3. And there is an envelope key that S3 uses to encrypt your file, and then S3 has a master key of its own that it uses to encrypt the envelope key, and then stores the encrypted media file and the encrypted envelope key separately inside of S3. Again, you can use the key management service, and if you don't want to use the S3 master key, you can use your own master key and have that be managed via the key management service as well. So a variety of different options available with S3, whether that's access control to your bucket or to your object, whether that's encrypting the object in flight by doing client-side encryption, or at rest by doing server-side encryption. Let's talk briefly about Amazon CloudFront. So Amazon CloudFront is AWS's content delivery service. We have 53 edge locations currently. There is also on-demand and live streaming that CloudFront supports, so you can do both on-demand as well as live streaming. Supports both HTTP and RTMP streaming, RTMP for video on demand, and then HTTP for both on demand and live. And there's also native support for smooth streaming capability. So you can just upload your media file into Amazon S3, and you don't need to run any media servers. CloudFront will be able to deliver it in the smooth streaming format to your clients or to your devices. You can set custom TTLs, any TTL value on your file, whether that's the manifest file or the fragments, and we'll show this in the demo as well, how you can set those TTLs and what the right values or what the appropriate values should be. There's also TCP optimizations between CloudFront and the origin server. That origin server could be the Amazon S3 bucket or an Amazon EC2 instance, which might be running a media server. And TCP optimizations such as persistent connections or scaling the window size and just optimizing the network path so that the download of that file from the origin to a CloudFront edge location can be in a best possible, like with low latency and high throughput. This is especially important for a live streaming use case where you want to avoid any sort of buffering or slowness. So that's where some of these TCP optimizations help. And then you can also customize the content that you're delivering from CloudFront based on the devices that viewers are coming on or the geolocation or the language. So you can use some of those headers that are coming into the as part of the request and use that to customize the delivery and the caching of content at the edge. From a security perspective, there's a variety of different features, again, that CloudFront provides for securing your delivery from CloudFront at the edge of the CDN network to your viewers. So you can use custom SSL certificates, and you can use your own domain name when delivering your content to end users. You can enforce HTTPS delivery. So you can redirect HTTP to HTTPS and always make sure that every viewer that's downloading content or your media files from CloudFront is only over HTTPS. Again, you can use signed URLs or cookies. So with Amazon S3 as the origin server here, you can use CloudFront's private content feature and make sure that only CloudFront edge locations have access to those files. And you see a big X there. The user cannot directly access the file from Amazon S3. And then you can also use, or CloudFront also has, even with the EC2 instances, when you're running a media server for either on-demand or live streaming, you can use EC2's security groups to restrict access only to CloudFront edge locations. Again, so there's features both from an access control perspective as well as delivering encrypted files. And then finally, CloudFront has support for access logging. So CloudFront will, you can check a box in the CloudFront console, and what that'll do is enable CloudFront access logs, which will be stored in Amazon S3, so you have visibility into who's accessing your content, who's downloading your content. CloudFront also has a reporting suite where you can look at different kinds of reports on usage and trends on your viewers and what they're downloading and watching. Talk about Amazon Elastic Transcoder. So this is a service for transcoding your media files from the raw format to a format that the different devices that your viewers use can consume. And Elastic Transcoder is a highly scalable, it's an easy to use, and it's a cost-effective service. You don't have to worry about the cost of all the different codecs or the licensing costs. Those are all baked into the Elastic Transcoder service. So you can simply pay one price to Elastic Transcoder and then transcode your videos into different formats. It's also integrated with other AWS services. So we saw how Elastic Transcoder can go to an S3 bucket, get your raw files, transcode it, and then put it back into an S3 bucket, or can talk to the AWS key management service to assume an IAM role and go ask for a key, use that key to decrypt your content, then transcode it, again, encrypt your content. So it ties closely with all of these other AWS services, so you don't have to worry about those things. The transcoder service will assume an IAM role and go talk to S3 or key management service for you. From a output perspective, all the popular output formats are supported, such as MP4 with H.264 and AAC. When we talk to customers, those are the output formats that we hear about as being sort of the industry standards. It also supports WebM with VP8 and Vorbis. And then adaptive bitrate transcoding is also supported, where the service will generate different bit rates for you and the different manifest files. Audio-only processing is something you can also do with the Elastic Transcoder. So it's not just for video content. You can also use this for, if you're doing, just only audio streaming. You can both for input as well as output. You can use Elastic Transcoder for that as well. And then it's a pretty feature-rich service in that, different customers and different use cases have different requirements. So, some customers need captions or visual watermarks, clipping your videos, and all of those features are available, and you can just configure them as you're setting up a transcoding job. From a security perspective, again, there are several features available with the Amazon Elastic Transcoder service. So you can do encryption at rest with Amazon Elastic Transcoder. That's supported. So getting files from Amazon S3 that are already encrypted, or storing encrypted files back into S3. Again, with key management service, we talked about that. Encryption for HLS streams. So when the Elastic Transcoder service is actually generating HLS fragments, it'll encrypt those fragments and store that into Amazon S3. DRM with the play-ready DRM packaging. So that's something that's new, and now it's relatively easy to just configure that by providing an encryption key as well as the license server URL. And then the transcoder service will manage all of that for you. And also integration with AWS CloudTrail, where what API actions or management call actions are being performed will be recorded in the CloudTrail service, and those logs will be saved to S3. A quick note on the media servers and the options available in the AWS Marketplace. So you have Wowza Media Server, Adobe Media Server, and a variety of other ISVs that have their offerings available on the AWS Marketplace. We also have partners that have a digital rights management or DRM offerings that are available, such as BuyDRM or EasyDRM. Those options are available in the Marketplace. And one thing to sort of keep in mind when you're using the Marketplace software is that the Marketplace software runs on Amazon EC2. And from a security perspective, all of the EC2 security functionality, whether that's integration with IAM, whether that's integration with the key management service or security groups, all of those are inherited to the software that you're running from our Marketplace. So that's something to keep in mind as well. So, in addition to the security features that are available with all of these AWS services that we talked about, AWS also has, rigorous audits that we go through for the infrastructure itself. I mean, all of these services are actually running on physical infrastructure. So all the way from facilities and the physical infrastructure, all the way up to the virtualization infrastructure, all of that is audited on a regular basis, and by different industry compliance standards. And you can see a list of those on the right. In addition, the MPAA best practices, the AWS infrastructure also has alignment with the MPAA best practices. So that's something more applicable to a streaming or media streaming delivery use case. And a variety of different services are covered, and content all the way up to pre-release content is covered under that audit with the MPAA. So identity and access management. So we talked about a lot of the AWS services and the security features. We talked about the compliance standards. But something to also keep in mind is who you allow to have access to your AWS resources. Because if unauthorized users have access to your AWS resources, then that could be a problem as well, because then they can go and access your media files. So when it comes to securing your content and securing the delivery of that content, you want to make sure that you're also taking advantage of the identity and access management service and the integration that other services have with IAM to granularly defining roles and groups the way you want, and what access different roles and groups have to different resources or features within the other services. So that way you can be sure that you are controlling access even to your AWS resources in a very granular way. And finally, along with IAM, something also to keep in mind is the AWS CloudTrail service. And CloudTrail provides you access logging for your management console as well as your API calls. So with CloudTrail, different services that we talked about, such as S3, CloudFront, and Elastic Transcoder, you can actually log who's accessing and making API calls. And then those logs are stored in Amazon S3, and you can have real-time notifications via CloudWatch logs. You can use Kinesis, or you can configure Lambda notifications. So that way you can get real-time alarms if an unauthorized user does get access to an AWS resource and performs an action. That's something you can be notified about in real time, and you can then act on that. So with that, we'll go into the demos, and I'll have Usman come here and talk about the on-demand and live demo.
Thank you, Nihar. Actually, can we go back to the presentation first?
Thanks. So thanks, Nihar, for sharing all the cool features. Now on to the fun part. So basically, I'll be doing a couple of demos here, and those are live demos. So let's pray to the demo god that it all works, nothing breaks. So I'll start with just kind of giving you an idea of what am I doing. And then I will just hop onto my laptop here real quick and kind of show you or walk you through it. So for the first one is actually the on-demand streaming. So in this scenario, we are assuming that you have a file, a media file that you've recorded or some kind of a content that somebody has. You upload it into S3, it lives in S3, and then we're going to use Elastic Transcoder to actually transcode HLS transcode and then segment or create HLS segments for that video file. HLS, in addition to creating the HLS segments, Elastic Transcoder is also going to use the integration with key management service to manage the keys and actually use those keys to encrypt the individual segments that are going to be then stored in S3, and then all these segments, the HLS segments, are going to be delivered via CloudFront. We're going to use JW Player for delivery, and really, if you look at it, the benefits here are, the manageability aspect. So yes, these are all great features. Nihar talked about signed URLs, DRM, cookie management, watermarking, all those cool things. But in reality, if you were to go and try to do it on your own, it's not that easy. So that's where the benefit or the utility of all these services or features that are built in these AWS services comes into play. That say, hey, you want to do encryption? That's fine. Just select it in your Elastic Transcoder, and while it's going to do transcoding, it's also going to encrypt the content for you. Great. How do I manage the keys? Well, KMS is going to manage the keys for you, and Elastic Transcoder knows how to talk to it. So all that stuff, really takes care of the management of the muck that you don't really have to do, and you worry about just creating the content and do your thing. Also, from a security perspective, you say, well, is it secure that I'm letting all these AWS services features take care of all that? In fact, it is. Because if you look at it, there is no human intervention involved in it. It's just a setup that you do, right? You're creating this, you're putting this file in there, you're selecting, go ahead, encrypt this file, and then when you're transcoding, go ahead, encrypt this file, so on and so forth. So you're not managing the keys. You're not transferring a key from one place to another place or content which is unencrypted from one place to another place. So even if you lose, or say a few segments of your content, or even the entire file for that matter, it's all encrypted. Let's say you lost the key as well. The key is encrypted as well, right? And it's all managed by a managed service, which is the key management service behind the covers. So basically, these tool set, these feature set, really enable you to build a really robust and foolproof application that's dependent on the use case, whether going back to, hey, your mom sharing videos or a studio wanting to do something. So very quickly, what are we doing here? Media owner sends their files to an S3 bucket. All right, there goes the file. Then the media owner goes, sends the key, that's their master key that you own, to AWS Key Management Service. Key Management Service also gives you the capability to manage master keys on your behalf. So again, this is going to the level of security that you're looking for. If you want to manage your own keys, by all means, do that. Use Key Management Service to generate the envelope keys or encryption, decryption for you. Or if you want AWS Key Management Service to manage the master keys for you, you can do that as well. In this case, the media owner sends the key to Key Management Service. It actually encrypts it, sends it back to the media owner. Media owner at that point launches an Elastic Transcoder service. And with the Elastic Transcoder service, it sends it the encrypted key. So notice, it is the encrypted key, as well as the file. The Elastic Transcoder now has a role. Nihar talked about IAM, Identity Access Management. That's where you define a role. That Elastic Transcoder service can actually call Key Management Service on your behalf. No human intervention in there. It calls Key Management Service on your behalf, says, hey, I have the key. Can you please unencrypt for me? I need it to encrypt the actual segments. It gets that key, encrypts the actual segments, stores it
back into an S3 bucket, which is the output bucket. All right. Now, at this point, your output bucket has the encrypted HLS segments ready for delivery. We use JW Player to deliver it, and we front it with CloudFront. Basically, at this point, the encrypted segments are requested by the player through the CloudFront. The encrypted segments are now in the player. Now, the player needs to request a key to unencrypt these segments so that the viewers can go view those. How do they get that? So in that case, you can build a simple application where it's say a couple of EC2 instances running a web server, has a DynamoDB backend where you're storing these keys, and basically just and these keys, by the way, are encrypted keys, right? So then anytime a request comes in, the servers will send in those keys to KMS. KMS will then unencrypt these and send those back to the EC2 instances. These keys can be stored in memory, delivered back, and now here, your player has the unencrypted key, can go deliver, basically unencrypt the segments and then deliver to the viewer. Well, again, this is the nirvana, right? At the end of the day, that you want to control the keys, how the users get access or rights, etc. In my demo, I simply put those keys inside of S3. So while Elastic Transcoder is encrypting the content, the underlying encryption key is also stored in S3. So the player can request that key directly from S3. Whereas instead of, for the authentication purposes, the application will actually create a cookie on the browser, on the viewer's browser. And CloudFront requires or verifies that cookie before it delivers any of those segments. So it makes it even more simple. It's just a matter of basically me enabling the cookie functionality on CloudFront. So with that, let's go ahead and take a look at it. So can you please switch? Yeah, thank you. So here, what you can see here is my console. This is my S3 console. All right, need to go back. My S3 console here. This is my VOD folder. This is where all my files live. I'm going to use the Muppets Show as my input file that's been uploaded in there. I selected here, as you can see, there is a storage class, there is a server-side encryption. Nihar talked about as simple as, if I want to do server-side encryption at rest, I could just simply select this, and voila, it'll encrypt the file at rest. That's all I need to do. In this case, I haven't selected any encryption, just to keep it simple. So basically, this is my file that was uploaded somehow, into S3. Then I go into the Elastic Transcoder console. So this is my Elastic Transcoder console. There are 3 different things here. You see there is pipelines, there is jobs, and there is presets. Let's talk about each one of them. So first, let's start with presets. Presets are basically configurations or settings or templates, if you want to call them, right? Say you want a specific resolution, you want a specific aspect ratio, et cetera. You define those in a preset. Elastic Transcoder gives you a lot of system-defined presets, so a lot of devices or that we have. For example, for Kindle Fire, if you want to view the content, what would be the preset for that? An iPhone, Android, etc. So there are a lot of system presets defined. Basically, this is where you can go in and define a preset. Then comes pipelines. Pipelines is basically a concept of, you could think of it as a scheduler or a distributor or a distributed job manager, right? Or a job manager, rather. Basically, what it is just like any other distributed job, you create multiple jobs inside a pipeline. And the pipeline then makes sure that, first of all, your job is completed from start to finish. If it errors out, it's going to restart it or retry it or send you a notification, for example. It's going to make sure that it distributes these resources properly for your job, and also make sure that it applies the preset or the configuration that you have defined. So in this case, I've already created a pipeline. I won't go through the details there, but basically it talks about what is my input bucket, what is my output location, et cetera, what is the preset, et cetera. So I'm just going to simply go and create a job. So here I click on create a new job. I select a pipeline. I select the file, in this case. I'm just going to select my file here. The output key, I want to store it in the same folder under VOD/. Decryption parameters. So this is if your file was encrypted in S3 and you wanted to decrypt it, you can actually specify the decryption methodology, where do you go to get the key, etc. In our case, since the file was simply stored unencrypted, we're just not going to bother decrypting it. In terms of the output details, this is where the presets come in place. As you can see, there is a lot of different system presets that are predefined, right? So we're just going to simply do system preset for HLS video for 600K. Segment duration, I'm going to keep segment duration at 10 seconds. Output key, I'm going to call it MUP. That's a prefix to all the different TS files or the segment files that are going to be generated. I don't want to create thumbnails. I don't want to rotate. And I don't want to do any clips or captions. I do want to do a playlist. So the name of my master playlist here, playlist format, I'm going to use HLS v3, put it in the master playlist. In terms of content protection, this is where basically it is asking me if I want it encrypted. So I say, yes, I do want to do HLS AES encryption, or I can select Play Ready DRM. So if I just simply select Play Ready DRM, it would give me the options for Play Ready. If I don't, I simply go to HLS AES. In this case, I'm just going to say store my key with the variant playlist. What that means is that the key that is used to encrypt these objects is also going to be stored in the same /VOD folder, the path that I had to store my segments. All right. And then I simply go and I say click and create a new job, and it'll start running the job. It'll take a little while because the file is big. So I have pre-created this stuff here. So as you can see, here is my mup.key file. This is my actual key file, which was used to encrypt these segments. M3U8 file, that's my manifest file. And then all the different segments that were generated for this Muppets video that I had. OK, great. So now I have the input file, I have the output file, the output segments in HLS segments, AES encrypted, ready to go. Great. Now let's go to CloudFront, right, which is my CDN, which is fronting my origin server. So basically, in this case, I've created a distribution. It's a web distribution, as you can see. I have access to a domain called Edge Reinvent. Basically, I'm using an SSL cert, a branded SSL cert, new feature that CloudFront has for Edge Reinvent. Basically, all my interaction, whether that be getting the keys or getting the segments or manifest file, whatever have you, it's all going to be over SSL or HTTPS. And it's pointing to my domain. In terms of the origins, I have my bucket /VOD. And I have my origin access identity. So this goes back to, remember when Nihar talked about access management on S3? So on S3, nobody has access to your content, right? How does CloudFront or how does Elastic Transcoder get access to this content? It's all through the IAM roles. In the case of S3 specifically, there is a thing called origin access identity that you define for CloudFront. And S3 gives the access to the CloudFront distribution with this specific identity. So the idea is that if a user tries to go straight to S3, they are denied. Their only way to access the content will be through CloudFront, and that's where origin access identity comes into play. A little bit about behaviors. So here, there is going to be a cross-domain.xml file. It's basically accessible over HTTP and HTTPS. Anything else, the key files, the manifest file, the chunks, everything is going to be over HTTPS. And here, the trusted signer is where I've defined the cookie behavior, right? That's where the CloudFront is going to actually, when a file is being requested by the player or the viewer, CloudFront is going to make sure that the cookie exists and it matches with the server that actually created that cookie in there. All right, great. So let's go. This is my application, basically right here. edgereinvent.com/signed content. This is like a web page, simple web page, a couple of EC2 instances hosting this site. What this does is, if I click on this link right here, it can generate a signed URL for a content. Or if I click on this right here, it will actually create a signed cookie. This is where, just imagine if you have an authentication authorization application, this is where user logs in, right? In this case, user can just simply click, and we assume that the user has logged in, and it will generate a cookie. So looking at the resources real quick, are there any cookies? The site has no cookies. All right. So once we click right here, the cookies will be created, okay? And we're just gonna go and this guy here, that's my Muppets file that was transcoded. And I'm gonna go and start playing it. And as you can see here, it started playing it. So what's happening? Let's first look at the cookies. As you can see right here, there are 3 different cookies that are created by this app. And CloudFront is checking, verifying that the cookies exist before any of the segments, before any of the keys are being sent out. And if we look at the developer tab here in the network section, as you can see here, it is requesting the mup.key file that was generated. It's also requesting, anytime it's requesting the segments. So for every single segment, it's also requesting the key file to be able to actually go and play that or unencrypt that object to play that particular segment. All right, so that was the demo for our on-demand streaming. So as you can see here, it's our 10-second segments. Every 10 seconds, it actually requests the key and the segment. All right, so can we switch back to the presentation, please? Thank you. All right, so we talked about this. Now, the secure live streaming piece, right? So in this case, what we're doing here is basically I'm using an EC2 instance, or actually a pair of EC2 instances that are running nginx with the RTMP module pre-installed in it. And that's basically for RTMP ingest point. Then it uses the FFmpeg that's pre-compiled with the RTMP module for actually transcoding into HLS segments. So you get an RTMP stream, you use FFmpeg to transcode, and then your nginx is encrypting individual HLS segments, okay? And it's generating keys for those segments. RTMP module for nginx supports RTMP, HLS, MPEG-live streaming. If you need more information, it's a GitHub project, as I said, open source. Take a look at it. Very, very simple to deploy. All I did was basically simply launch an EC2 instance with an AMI that has nginx, and then added the module in there. Okay. So what's happening? RTMP stream through a device. In my case, I'm going to use my Kindle HDX, as you'll see. And I'm going to use the camera for the Kindle HDX to actually capture the video here, and it'll generate an RTMP stream which will go to my EC2 instance that's running nginx. Notice I'm using Route 53 in between to do DNS failover, and the reason for that is I want to run it in a failover mode. So in case, say, something wrong goes on with my EC2 instance, Route 53 has the built-in capability for health checks and failover. So in case something happens to the primary, it can automatically flip to a secondary EC2 instance in the case of a failure. You can also launch it in a, say, active mode, and we'll talk about it towards the end of my presentation. But in this case, I'm just doing active-passive mode. So in the case of an issue, it'll simply fail over. Then basically, my nginx receives the RTMP feed, uses FFmpeg to transcode and encrypt the segments, and then they're being delivered basically to the JW player. But before that, JW player will call the application which generates the cookie. That's what we talked about, and I demoed that for my on-demand piece already, right? And then the segments are being delivered through CloudFront, as we talked about. And there is your encrypted segments, etc. So let's switch to the other screen, and I'll give a live demo. So I'm going to put the configuration here for okay. All right. So basically, here's my EC2 console. And as you can see here, there is an EC2 instance, an M3 medium that I'm running. I gave it actually a public IP address or Elastic IP. That's how my Kindle HDX is going to go and connect to it. And basically, I also opened ports for RTMP, SSH, so SSH and RTMP ports and the HTTPS and HTTP ports, because RTMP for ingest, for ingress, because Kindle is going to go connect to the EC2 instance over port 1935. So you want to make sure that you have it, pinned down to the specific IP address range for where the Kindle is going to be. And then for a delivery perspective, if it's port 443 for the keys and the segment files that are going to be delivered. Then there is the CloudFront distribution. Basically, if I go back to the distributions here, there is the live streaming distribution right here. And as you can see, basically, again, I'm using the same domain and the SSL cert. For the origins, I have live origin encrypted at reinvent.com. That's pointing to the IP address of my EC2 instance through Route 53. And it's a custom origin. In terms of the behaviors, now, every single thing, the TS files, the key files, anything that's in /HLS directory is delivered via SSL. And there is the signed cookie that we talked about. Okay? So with this, I'm going to start the live stream, and I'm going to try to stream you guys right here and see if it works. So first, let's log into my instance right here real quick. So I'm doing an SSH into my instance. All right. So if I do a PS on it and check on my nginx, I see that the nginx process is running. I check ffmpeg. That's my transcoder. As you can see here, the first one shows that there is actually a live stream coming in, and that's through this Kindle. And I go back in here, and I click on Live HLS Encrypted, and see if it plays it. Voila. So as you can see here, it's right now streaming the room. There aren't a whole lot of people. Last session. So I'll just leave it right here. You can wave at it just to make sure that it's working, right? And very quickly here, the cookie was already created because we created in the case of our on-demand, right? And then as you can see right here, so if you could look at here, there's a live demo.m3u8, that's the manifest file that's being generated. Then there is the key file, and then there is the individual segment. So every single segment is being encrypted by a key, and it is being served through the same mechanism through CloudFront. Okay. So I'm gonna pause this right here. If you can move back to the other screen, thank you. All right. I don't want to break my Kindle. So a few best practices here. So first of all, you want to make sure that you're limiting access to port 1935. To only trusted resources. In my case, I had it blocked only for my Kindle device. Because if you have it open, I mean, guess what? Anybody could just go in and start sending packets on port 1935. You do not want that. You want to define proper TTL settings for the .ts files and .m3u8 files. So TS files being the segments and M3u8 files being the playlist. I showed it in the CloudFront console in the behavior section. That's where you define the TTLs. So you don't want to define them as 0. Anything that's low but not quite 0 is the way to go, because you don't want to put unnecessary burden on your origin servers either. Negative TTLs is an important one. So oftentimes what happens is that, if somebody knows the sort of say pattern of your TS files, they can request a segment which is ahead of what it's supposed to be. And once it's going to get a 404, then at that point, that's not good, because then when the stream actually gets to that point, and if it's cached inside of CloudFront, then you have that 404 cached. So that's why you want to put the negative TTLs for that kind of a purpose. Geo-blocking, that's another one. Again, going back to CloudFront settings, you can very easily say which countries, which specific geos I want to have this stream go to. You want to rotate the key files as often as possible, and I'll talk about it. In my case, basically every single segment has its own key. So we are generating a key for every single segment. And you want to randomize the pattern for the .ts files. Again, going back to the point that I made earlier, that you don't want it to be really predictive, because if people can predict these, right, then there is a possibility that they can capture these TS files. But then the point being, it's all encrypted, and then you have the keys that are encrypted, right? So it becomes, again, depending on the underlying solution that you implemented, you can make it pretty robust. So this is the settings that you set in at the EC2 instance level. Very quickly, this is the behavior for TS files and M3U8 files for TTLs. You can geo-restrict on CloudFront. This is the RTMP HLS configuration on the nginx layer. So this is where my EC2 instance had this configuration. I'm going to mention a few things here very quickly. To enable encryption, you just simply say HLS keys _keys on. And then you define a pattern for those underlying segment files or the key files. And in this case, I'm using the timestamp, and it's rounded to 250 milliseconds. And then there is a location where you store these key files. And then basically where do you want to return the key files from, or where your player is going to go and request the key files from, right? So in this case, I was using an SSL. So even your keys are being requested over SSL. And then how many keys, how many fragments per key you want to do. In this example, it's 2. The demo that we did 1 key per segment. And then lastly, I mentioned earlier, the setup that I had for nginx was really a failover, active-passive model, right? So if my primary fails, Route 53 will switch to the secondary. Now, nginx RTMP module gives you the capability to enable HLS fragment slice line. What that means is that every single time it is creating these segments, they start at a particular timestamp. So basically, both of your servers can be ingest points, or both of your nginx instances, servers could be ingest points, and they can create these segments. They're aligned at a particular timestamp. All right, what happened there? Do we lose it? So they could basically be aligned so that then you could be running it in a active mode, so that if one fails, the other one automatically takes it. So last slide, a quick recap. This is the architecture that Nihar talked about. How do you do streaming? This is simple streaming if it's on demand or live. Let's fill in some colors. How do you make it secure, right? So key is key management service. It'll save a lot of trouble for you. You can do it all yourself, manage the keys, encrypt, all that stuff, but leverage the features that are built in for you, that take care of this management. In this case, key management service and its integration with all these different services. So very first, the media owner can create a key or send in a key into key management service. And then every other service like Elastic Transcoder, like EC2 instances, all of these, even S3, can use the built-in integration with key management service to make calls and manage these encryption keys on your behalf, so that there is no human intervention involved, and it becomes very nice and manageable. And then lastly, you can use CloudFront cookie feature to make it even simpler for you. I mean, I remember in the absence of this feature, customers would ask me, hey, how do I deliver my key files? How do I deliver my manifest files? If they're not encrypted, well, signed URLs. But just imagine, in the case of live streaming, how hard it is to create these signed URLs on the fly at the same time when the segments are being created, the manifest files are being created. So it's not that easy to kind of make it in sequence, right? So the signed cookie capability with CloudFront takes care of that as well and gives you feature set that allow you to build an even more robust and secure workflow. So with that, thank you very much for attending, for the time. I hope it was entertaining, the demos part at least.